Hello, my name is Myung Kim, and last week I talked about two two types of volatile memories, which are the dynamic RAM and static random access memory. And today I'll talk about a most famous and most commonly used type of non-volatile memory, which are flash memories. The flash memory structure looks like a regular old MOSFET with a little twist, an extra gate known as the floating gate. And the floating gates, the one difference between the floating gate and the regular gate is that the oxide layer between the substrate and the floating gates are really thin. So thin that if we give bias to this both control and bit line and drain channels, the carriers in the substrate region will move through a floating gate by a tunneling or a hot carrier injection effect. And if there's a and those carriers within the floating gates will change the threshold voltage of this MOSFET, and which is shown in this IDVG curve of this device. And we can know that this device stores information by a change of the threshold voltage, and we check it by sending a checkup signal. This one says VT read, and if there's any change in the threshold voltage, we know that the flat and this memory block stores a 1 bit of information. There's mainly two types of a flash memory, NAND and NOR flash memories, and aside from their name, there's a huge difference between those two flash memories, which are the structures. As you can see, the NAND has a series connection while the NOR has a parallel connection. This will become a huge difference in the scaling department, because in the NOR memories we need some metal poles in order to operate each cells. Meanwhile, we only need 2 metal plugs to operate the whole block. And so we use the NAND flash much more because of the scaling and the integration of our semiconductor devices. And finally, in order to enhance or advance more the integration of the circuits, we make the vertical NAND. We know that the NAND has this series connection, and we just make it vertical in order to enhance it, and it is this. Thank you for listening. This is me, Myung Kim, of the semiconductor class.